Welcome to our first video. This is going to be 1.1 discussing degrees and radians. This will be part 1, and in part 2 we'll do arc length and sector area. So to get started, just draw a XY axis on our notes like this. Just know that this is your 0 degrees, your x-axis, 90, 180, 270, and of course back at 360. And this is all assuming you rotate counterclockwise. And that's going to be your first positive rotation if you're going that way. If you were to rotate clockwise first, you would then note that that's considered a negative rotation. So just knowing that, there's a couple of vocab words we can add in. Right here, you're going to call that your initial side. Some books will call it your fixed side, meaning it's always at your x-axis. And this is the one that pretty much all books will use, that right there is your terminal side. So that's the side that's going to rotate around the whole coordinate grid. Alright, so let's do our first couple practice problems. We'll start by just drawing our typical XY axis here. So draw your axis. You can just assume your fixed side is right there, 45 degrees, about halfway up in the first quadrant, and you're done. Part B, same exact thing, except it's negative, so we're going to rotate in the clockwise direction. So I'll do this in red for you. Here's our initial side, there's our fixed side, rotate, there's your negative 90-degree angle. Now you can pause the video here to try the next two on your own, and as soon as you're ready, just unpause it and I'll put the solution up. Okay, so to do these, exact same thing. You draw your axis, y, x. It might help you to put 0 here, 180 here. 225 is going to be halfway in the third quadrant, and there's our rotation. 405 is pretty weird because obviously it's more than 360. So what you do is you're going to rotate 360 degrees, like so. And you can think of 405 as exceeding 360, so just subtract it. Notice you have 45 left over, so this will just continue back to the first quadrant, and there's your leftover angle, and that's your solution. Okay, now let's go to the next one. Convert degrees to radian. So to do this, just understand what a radian is. So notice how these are all in degrees. A radian, quite simply, so we'll just put a note here. A radian. To do this, I want you guys to draw a circle on your notes like that. We're going to draw a radius right here. So your circle could be any size because a radius will match up with whatever circle you have. Then what you do is imagine you take this radius right there, and you're going to lay that radius, and try to be pretty precise, on top of your circumference, so like so. That angle you just created is considered 1 radian. Okay, so we'll call that our theta right there. That's Greek. It's just a common variable for an angle. That's going to be about 1 radian. And if you want to measure it, it would be about like 57-ish degrees. So I tell my students round to 60. So something really simple to think about is 1 radian is going to be about 60 degrees, which would mean 3 radians would be about 180 degrees, and that would mean 6 radians is about 360 degrees. So we'll just put that in a little box for us here. Now why that's powerful is because if you think about the idea of 3, many teachers will tell you that pi radians is exactly 180. And that's how we say 3 is about 180, because pi, as we know, is 3.14. And 6 radians, of course, that's related to 2 pi, would be exactly 360 degrees. So for this one, let's do a 3D box. So in my class, I always tell my students, 3D box means like super important. So we'll just put a nice 3D box here. So on our homework notes, you're going to need this example, or need these notes rather. So let's 3D box this. Really pops out in our paper there. Okay, so to do this, it says convert each one from degrees to radians. So I'll just zoom in here for us. All we're going to do is take 60 degrees and multiply it by your conversion factor. And if you look back at our notes here, we know that this is true, that pi radians is 180 degrees. So what we're going to do is multiply 60 by pi over 180 degrees. The degrees cancel, the 60 reduces to 1 and 3, and now we have pi over 3 radians, and there's our answer. So 150, we'll do the exact same way. Pi over 180, cancel the degrees, reduce by 30, so this would be 5 and 6. Now we get 5 pi over 6. Notice how I'm not going to put a label, because if there's no label, we can assume it to be radians. Now I'm going to pause the video, or you can pause the video here. Try the next two on your own, then unpause it once you're ready. Okay, so to do these, same thing. Negative 45 degrees times pi over 180. We're going to reduce that by 45 to 1 and 4. Negative pi over 4 is your answer. Now 107 is pretty interesting because 107, when you try to do this, has no shared factors, which is fine. You just cross out your degrees. 107 pi over 180 radians is your answer, and you leave it there. Okay, so to summarize, let's finish our notes with the radian definition. So you can think of it quite simply as the measure created by 1 radius unit along the circumference. And that's of any given circle. So I'll just put that on the side here. Let's move that to make that nicer. Oh, it's not working. One more time. Okay, there we go. There's our definition of radian, and we'll highlight that so we know. We'll come back to that later. Or in case you need to look at this. Okay, so to finish that section, let's just put an important note when you're converting from degrees to radians. You want to multiply by pi over 180 degrees. And let's write that a little nicer. And let's make a nice box like that. Ooh. There we go. Nice box. Okay, so let's move on to our last ones. So notice for these, it's just the reverse, so radians to degrees. So all you're going to do is do the reciprocal of what you just did. So multiply by 180 degrees over pi. Okay, so let's make a nice box for us right there. And let's try it. Pi over 6 times 180 over pi. Cross out the pi's, reduce 1 and 30, and then 30 degrees is our answer. There we go. So for 3 pi over 2, exact same thing. You're at 3 pi over 2, multiplied by 180 over pi. Reduce the pi's, reduce the 2 and the 180, 270 degrees. Now just do make sure you put 270 degrees, because if I were to write 270 like that would actually imply radians, which you wouldn't want. So make sure you always put degrees on these answers. You wouldn't want to get marked wrong for that. Okay, so pause the video right here so you can try the next two on your own, and then unpause it and check your answer with me. Okay, so to do these, let's try exact same thing. Multiply by 180 degrees over pi, cancel, cancel, reduce. Answer is negative 135 degrees. And last one, this is kind of weird because it's just 3. So don't be freaked out by that. Multiply by 180 over pi. Nothing cancels, so we're going to write 540 degrees over pi. And that actually is your answer. It doesn't reduce further than that. And if you think about approximating this, just think of like, what's 540 over 3? And that would be about 180 degrees, which makes sense because we said earlier, for 3 radians, look right there, that's approximately 180 degrees. So that would work out there. So let's circle that. And that's the end of our first video. So here's what your notepaper should look like. Make sure you downloaded it from the website if you didn't have it. And after doing that, you can scroll to the bottom and you can see that you can do homework problems 1 to 9 to practice. So homework 1 to 9. You should be able to do those no problem. Okay, so you can check out the next video to learn this part 2 of this lesson. And make sure you check out Tomo's Instagram for some trig tips from my dog.